are exhibited by the folding of the different rock types. Structural mapping, it also includes the mapping of the lineaments. Lineaments are nothing but your dikes, that wherever the dikes are occupied, that mapping can be carried out because dikes are in a regional scale. We have geomorphological mapping. Geomorphological mapping helps you again knowing about the hills and your basins. Hills and basin will tell you the just a probable interpretation of what rock could be at a hilltop and a basin. Alteration mapping, which are associated with your hydrothermal alterations. It is, we are talking about a large scale alteration. A large scale alteration, as you can think about a greenstone belt. If you see a length of any greenstone belt, if I tell you the length of your Chitraduga greenstone belt, Chitraduga schist belt, it is about 450 kilometers, and the width is around 40 to 50 kilometers. So see the amount of alteration if it is having, because these greenstone belts are comprised mostly of your iron bands, metabasalts, and also at few places it has your argillite gravity. So if these units are getting altered with 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 a change in pressure and temperature, these are of your large scale alterations, and these will be obviously be recorded in the remote sensing data. So these are the different fields where remote sensing data are used. There is a small, very small case study, or in case a very preliminary, which is where if you see the lineaments at a certain terrain, you can see the lineaments where Dharwar Craton is written, and all the lineaments are in different trend. If you find this kind of lineaments, you know that most of the lineaments are associated with some deformation. So the lineaments will be of different orientation. Here orientation, I talk about the strike or the trend of the lineaments. So here the trend of the lineaments are mostly north, east, west, and few of them are northwest to southeast. So to your right side, you have one more image, little bit close image. It's an ADAS imaging where where we see that there is a step there is a step faulting created by this dike. You can see the dike, and it has been created by this north south trending some lineaments. As it is visible on the on this satellite, you can think that this is also will be visible on the ground, but this could make out as only through your remote sensing system, because what we are doing here, we are covering a large area. And also if you follow my cursor to your top part where the pink lines are concentrated, you can see that there are lot many concentration of your pink lines. So here this area is mostly this area is from your Krishna lineament zone, where many of the diamond bearing pipes have been discovered. So these are the places where we generally look for diamonds. And if this is just a preliminary stage, as I told you, this is just for you to interpret that you are seeing some concentration of your lineament. So next step is to go and do the ground survey. Once that is done, you can find out. So as we see this block area, if you see this particular block, white colored block here, under inside it you have a dike which is marked as green in color, and north south are your veins. And so these veins, we could see that in the field it was mostly a quartz veins. They were quartz reef which were rich in your lead and zinc, lead, zinc, copper, copper deposits, and even RE was also found in this deposit. So this generally will help you find out or localize yourself into a small area. So these are the basic uses of your. So these are basic uses. So this is one more a case study where it is just an example where we see that most of the hydrothermal alterations where porphyry copper deposits could be found in southeast Iran. We could even find some volcanic belts host with vein type in gold mineralization. You can see that how these alterations play a major role in giving us an indication and finding them in the mineralization process. And so rock alterations, hydrothermal alteration, other phases. So this is your Chitraduga schist belt, where you can see that by playing with different bands, which exactly these are the pictures I have taken from the presentation, where we can find out that few of the patterns are being created. in this image, if you see this pink coloration here, this pink color here, the round elongated body and the surrounding bodies, these are your granites. And inside it, we have this is a shale belt. This is a part of a Chitraduga shale belt, little bit south central part of a Chitraduga shale belt, where a inlier, if you know about inlier, it's an old basement which has been exposed because of your erosion. So this is the same rock. If you see this rock in the center, which is having an elongated part, and the surrounding rock is the same rock, and inside it we have the shale belt. So this shale belt, this is a phyllitic band, because different alterations have different bands in esters. So this is a phyllitic alteration band, which is being seen surrounding this particular elongated body. So it can be clearly distinguished. You can clearly interpret that what kind of rock it could be, or what kind of, just seeing this particular band features, it will help you understand, or little bit, at least you can give a vague idea to what could be presented, because this is in one case. This is another case where if you see this Chitraduga, this is a Chitraduga shale belt, and here you have one more arm that is the same part of Chitraduga, which has been extended to your south eastern south from southeast. It has been extended towards northwestern. That is also called as a this arm, Kibanhali arm. And so where it is mostly comprising of your metabasalts. So again, these metabasalts and the surrounding igneous rocks could be clearly identified, and seeing the shade it is showing, we can differentiate it. Once you know the geology of that rock, and once you overlay on top of it the image data, it would be very easy for you to find it out. So again, a few of these are again associated with, because in Chitraduga shale belt, the topmost portion is the Gadak, and followed by your few important deposits in the center. So this probably is, again, if people who have walked in Chitraduga shale belt, we know about a shear zone. So where mostly the eastern part shear zone, the center part shear zones are occupied by your gold mineralization, and in that we have quartz carbonate veins. And you see that there is one part here and another part here where it is more concentrated. So this part in the central part, this belongs, please follow my cursor, this part is the central part of your Chitraduga shale belt, falls in Chitraduga town, and that is a core portion of your whole Chitraduga fold. If I just simply tell about a fold, there is a regional fold which we can even see that how this shale belt is getting folded here, and in the center you can see a pink color, that is your Chitraduga granite. So just near to this we have the central part of Chitraduga shale zone falling in. We have a Halli deposit, and there again we have lot of gold occurrences associated with quartz carbon veins. So these are few things. Geochemical, again, not going much detail into this, because as we have other speaker who will be telling about geochemistry more in detail. So just to tell about a basic thing about gold. Gold is that it is present everywhere in the Earth's crust. You will be finding in ppm level. Ppm is in the sense of 0.005, or you can say that these are in the ppb level, parts per billion level. So in parts per billion level, in almost all the rock types you will find. But to get an anomaly, maybe around 10,000, or in case of your gram per ton, or in case of 1 ppm level, you need to have them in certain rock types. So those are the rock types we need to target. As we have told about the quartz carbon veins, these are the places where you will be getting them in about 1 ppm, or about 1 gram per ton of your gold dose units. So the quartz veins are more targeted here. Then also we have the host rock. The host rock would also have little amount of gold in it. So could be that it is not that as high as your quartz carbonate veins, but yes, obviously it will also have little bit about of your anomaly from the surrounding, or it is having a little bit higher than the crustal abundances. So if you go to look for a felsic rock, in the felsic rock, obviously it would be there at certain conditions. But if you see as a whole, it will rarely have any amount of gold in it. So you can see here at the average gold content in mostly your granites, and it is 0.003 parts per million. But as you go for conglomerate, see now why in conglomerate you have very high, because these are your placer deposit. In placer deposit, and they have the chances that you have the possibility of bringing the gold as it is from the source and bring it to the present place of deposit. So in placer kind of deposit, you will get very high amount of mineralization. And the average as in soil also, in any soil, in the crustal rocks, and again in the soil you have about 0.1 million of gold in it. So to have a concentrated amount of gold, you need to have at least structural control over it, lithological control also into it, and also associated hydrothermal fields. So coming to geophysics, again this is also our indirect tool. Actually a pre-recorded ad. So yes, there was actually a pre-recorded audio in it, which is telling you about the natural fields which are being used by the rock properties in it, which helps us understand what kind of rock is present there. So these are like gravity, magnetic self-potential, and magnetic telluric properties of any rock. So the artificial are again where we are inducing some kind of electricity into the rock, and then they help us understand what kind of rock, what kind of material may be present there, because depending on the conductivity and also the different properties of that subsurface content. So these methods are used mostly in the large scale mapping, and also a few places in the detailed exploration, because once you know that these detailed exploration methods are also carried out, because as you know, in case of your artificially induced processes of geophysics, you can increase the distance between the poles, where you can have a much greater depth. If you have a more greater depth of penetration, you have more information about the depth. If you have a closer spacing, then the depth persistence is not much. So depending on the requirement of the geologist, the geophysics team helps us do the detailed exploration of the rocks. So this is very okay. So this is just a small example where we take an example of a man standing on a ladder, and we have an ore body underneath. You can see that the concentration of an ore body is at the center, and this is where the gravitational curve is. If you see the place where the tree is, there is no body underneath, so you have the curve very flat. As you go towards the center part, where a gravitational high gravity body is there in the center, the forces increases. So this is just a small concept where we can try to understand that how the subsurface content of any body underneath could be detected by the geophysical processes. Very simply explained by this cartoon. Anybody could simply understand it. So this is how aerial, because we have different divisions in Geological Survey of India. We have aerial survey, we have ground geological survey, geophysical survey, and marine geophysical survey. So aerial geophysical survey, mostly we have how aerially, depending on the scale also. This is also on the on the amount of the scale how it is being carried out. So all these geophysical processes help us find out the different minerals present on the surface and underneath. So as I told you that the spacing is very important in geophysics also. So closely spaced ground geophases along with your gravity, magnetic, self potential and resistivity will certainly help in narrowing down the target. As you know that the gold, they don't have actually geophysical signatures, but the associated lithology, because we have basic rocks. So basics, they are highly magnetic, and then associated structure could be either fault fractures. This could be readily targeted and found in a resistivity survey, and followed by the level of weathering. So all these things help us indicate or help us monitor where the gold is present. So most of the gold deposits are associated with the considerable amount of sulfides. As I told you, sulfides are mostly associated with the gold. So in such cases, electrical methods are very helpful to find out the gold deposit. Okay. So then other thing is, in case of load or fracture kind of deposit, what happens? There is low resistivity and high chargeability. So which characterizes the gold present in the auriferous. Auriferous lode system, again, it is associated with the weak plains along which the hydrothermal fluid have come in. So they have this property. However, as I told you, each deposit will have its characteristic geological significance. So now we need to know that how and when to use which property to find out the gold deposit. So as a whole, what we have studied till now is how these processes are helping us delineate from a larger area to a smaller area. So how the area selection has been carried out from the regional scale, right in the recognition survey, that is in finding, that is from remote sensing, that is aerial. Then we also have the geophysics, where we have aerial survey. Then we have the chemical signatures associated with them, that is the alteration processes, which is detected in most of your remote sensing studies or the asteroid images. So coming to sorry. So now coming to few of so coming to the importance. So coming to the importance of the structural mapping here, we can find out the lineaments, faults, shear zones, and then we can find out the basement, buried channels and cavities for geophysical methods. And then these are again very conceptual studies which tells you the direct detection of iron ores, barytes and chromites from geophysical studies. Indirect method, as I told you about, for a very best example is your gold, where we don't know exactly how it is, but associated rock types, associated lithological control and associated mineralization generally tells us about it. Obviously, the depth persistence which can tell us, uh, because a specific subsurface ore geometry will come into picture after the geophysical processes. Estimating the reserve would be not that possible, but we can tell about a resource, and to some extent we can have the ore body by modeling, and also aiding this with drilling. It will be a great help where drilling is associated with exploration. So what it basically provides, it provides a window to the subsurface, especially in areas of thick cover. For example, in India, we have many of the places which are inaccessible, because of your huge vegetation, and also because of your huge amount of weather profile on top of it. So this helps. This technique truly helps you, and also because most of the concealed deposits have been explored, we have to go into subsurface exploration. Okay. So geophysical methods, as I now little understanding about the stages. I guess till now, at least I could tell you the different. Yeah, I could tell you just the different processes and different methods and different techniques or different tools which are being used to find out and help in your exploration processes. And so here is a little bit detailed of what happens in different stages of exploration, and how how we try to use them, and how the steps changes to make a resource to a reserve reserve deposit, because it should be economically viable, and also it should in turn be a mineable, so that the exploration becomes fruitful. So if you see here, we have the geophysical processes and the different methods: resistivity, magnetic, and self potential. If you see here in G4, the spacing, if you see, it is hardly 200 or 400. Later, followed by G3, it decreases. It becomes 100 to 200, and much less in the G2 stage. So you can think, you can understand how it follows. So so till now we have talked a little bit all the processes here, and the selection of the area for remote sensing, satellite imagery studies, and then how what are a few geophysical processes, how it helps us, the geochemistry, as I told you, perogeochemical, pathfinder elements, stream sediment sampling. So these are the various exploration strategies which have to be kept in mind. This is step. This following slides is little comprehensive, which deals with the different exploration stages and how it is being carried out. Recognitions, preliminary, general, and detail. So this we think we'll take in detail, and we'll conclude the session. So this geological maps, in many of the geological maps, as you know, that most of the area has been covered in 50,000. Most of the area has been geologically mapped in India, in the scale of 50,000. So you will get many informations in that scale. If you consider a scale of the map, you have a scale of 1:50,000, and you also have a scale of 1:12,000. So and the scale is so important that to know the detail of any kind of mineralization, you need to have a much larger scale larger scale maps with you. So this is what is more easy to explain in case of recognition survey. So you have a regional scale mapping there, and as you go into the lower stage of geology, you see that the maps become more and more informative, as you means that the preciseness or the resource indication becomes more and more increased. So this is about, okay, what are the most important guidelines being taken into consideration? See, this is dependent on the stratiform, strata bound, and tabular kind of deposit, and that could be regular or irregular, because most of the deposits are of different dimensions. In case of gold, most of the deposits here are associated with the quartz carbonate veins, or they are either lenticular bodies. It could be occurring as an echelons. It could be silicified linear zones or composite veins. So these are mostly we are looking for in case of your gold deposits. So in that, what we go for, what kind of exploration we go for, we will be talking about. So in case of your lenticular type of bodies in the very preliminary stage, yeah. So what generally happens in this? So we see that there is an abrupt change in thickness and grade, because at few places you have a very high nugget effect of gold. At few places we have lean amount of gold present in. So they have a pinching and swelling characteristics. So if you have any gold, for example, consider that this is a lenticular or a vein type of deposit. You see that the pin at certain places it is very much thin, certain places it is swelled. So this happens all because of the space it is getting for the hydrothermal fluid to get inside into the weak zones. So in that places wherever we have a thicker area, there you will get a high anomaly. But wherever you have a thinner area, the anomaly is very rare. So those things have to be considered in case of this kind of deposit. So let's say that you have and now we will talk only about this body, because most of the gold deposits are in this format. So here starting, we'll go for the remote sensing studies. Again, in the remote sensing studies, we will see the rock type present in it. We'll go for the geophysical studies. Geophysical studies, as we have told, mostly we'll go for cell potency and resistivity studies, because in that the sulfide minerals are associated with them. That thing will be carried out, and these things will be carried out depending on the scale of, depending on the stages of your exploration, keeping in mind. So once that is done, we come to a place where we find that in a small area, maybe around 1 kilometer, 2 kilometer, there is a very high rich zone. And once we reach that zone, now the next step is that we have to take the sample in that. So the samples are carried out in certain interval. This interval could be either 200 meters. So again, one more sample we'll take here, 200 meters. So depending on the, again, on the stages of exploration. So that 200 meter I'm talking about again at G4 stage of investigation. As you go lesser and lesser, the interval becomes lower and lower. So it may be that at the next stage we'll go for 50-meter interval. Again, as we are talking about a lenticular body and also irregular shape and grade. So in this we have to keep in consideration that the shape is really irregular. So all these things will be kept in mind. And finally, when we go for G3 or G2 stage of investigation, the spacing will become more and more less, maybe around 10 to 20-meter interval. So once that is carried out, associated with this, we have drilling. Again, drilling comes into picture. So drilling is a process where now we have a cost effective. It is having certain amount, because we cannot just simply drill anywhere. And if the drilling is like unsuccessful, it will be a huge loss. And so in that case, we generally make the best to drill only at those places where we get very high values. So these are the places where we'll get high values. These are the zones, the places where it is much thicker. These are the places where we get very high anomalies of your gold. So in that case, what we'll do, we'll try to drill it at these locations only. So maybe only at this point we will try to drill. So the drilling will be carried out in different levels, as we talk about G4, G3, G2, and G1. So at G4 stage, may or may not we will be getting drilling, because generally we don't get the drilling in case of G4. But G3 we can do some amount of drilling where we target only the best possible locations where we get the gold. So the spacing could be either in the form of 200 meter space. So we do the drilling. So after this, if we go for the next stage of drilling, then again we have much narrower. It could be either 100, and finally come to about 50 meters at G2 stage of investigation. So again, keeping in consideration the irregularity of the shape and grade of the body. So this is about a typical only for gold type of deposits, only for gold deposits. So just erase this. Give me. Okay, fine. So now this why I concentrated, because most of the gold deposits are in this format. Coming to, yeah. So this is what, depending on the, what I will do, I'll share this slide with you. Please pardon me if I could not explain everything to you, because few things are there which I wanted to say, but it is mostly in the statements. So I want you to bear with me for time being. Wait, yeah. So here, so this is what we are talking about: lenticular bodies, including bodies which are forming in anachron or silicified linear zone bodies. So what happens in the G4 stage? You have the scout drilling. If necessary, we do. If not, we generally don't take into consideration. But in the G3 stage, we have in the spacing of 200 to 100 meters. Followed by in the G2 level, it comes up with 100 to 50 meters. So you are understanding, right? So consider a block here. Just in 3-dimension where I'm talking in the very first. This is a 3-dimension body. So you have an ore body here. So you have an ore body. So this is an ore body, and this ore body on the surface is having a strike, and on the subsurface also it will have a depth. Let's consider that it is inclined. I think by now everybody knows that about inclined body. So if the ore body is inclined, so consider that this is the inclination. So what we generally do, we have to drill it to find out the amount. because on the surface we already have done some bedrock sampling. That comes again in case of sampling technique. So that has already been carried out. So now we go for drilling. So drilling points, as I told you, in G3 we have 200 meters. So this is one borehole here. The borehole is around 200 meters. So this distance is 200. So this is about 200 meters. So the drilling is done. So if you see the sectional view here, this is the place and the drilling is done in this manner. So why inclined drilling? It is again based on the orientation of the ore body. So once that is done, we can find out a true width. We'll get a true width of this. So this is all on the simple mathematical calculation where the trigonometry is kept into picture, where the angle of this borehole with the ore body should be 90 degrees. So to keeping in consideration the 90 degree between the ore body and the drilling, that has to be kept in mind, and we have to drill that place. So as I told you, in all the places it will be at this depth about 200 meters. And also we need to see that at what depth it is intersecting, the vertical depth. So vertical depth would be this depth. Okay, understood. So vertical depth from this surface. So if I see this vertical depth, it should intersect at around 60 meters. So why 60 meters? Because we tell that the upper oxidized zone, maybe around 30 meters, is generally taken as oxidized zone, and only below it we get a fresh zone. So that 30 meter we have to exclude, and below it we tend to take. So this is the first level of intersection. This will be carried out in G3 investigation. So followed by G2 investigation, the distance will be lowered. So distance, when it is lowered, it comes up to 100. But again, when you see that 100, now the places where it was vacant, the drilling will be carried out, and also we have to drill at a place, again little bit extended, because I have to take this and drill it at a place where it will intersect this at 90 degree. But again, the vertical depth has increased. So the vertical depth here, it will be around 120. Are you getting it? Are you getting, please, my dear friends? It is very easy. So first vertical depth is 60 meters, second vertical depth is 120. So if I say here, these are my G3, and also in between I have few boreholes which is the places which have been left out, and the later G2 investigation we carry out, which are carried out at behind the G3 borehole points. Maybe this is behind. This was carried out at this place. So this is the point from where the second level of borehole will be carried. These are called a level of borehole. So level of borehole is done in this manner. So and also we take into consideration the strike distance. These are the strike distance. So strike distance here, it comes up to 50, or again more or less depending on the commodity, depending on the importance and the commodity. So this is your G3, G2, and G1. G1 generally GSI is not carrying out, because that is the place where mining and the development takes place. So in GSI, Geological Survey of India, we do up to G2 stage of investigation. Okay, so now gemstones, all these things, I'll share this and you go through them, because today mostly the most exploration strategy we have to talk about only for gold. So see, few things. By now, I think I'm just about to complete it. So few things which I want to add to this are geological studies for mineral exploration. What are those? That is relying on the identification of the rock type, identification of the structure, identification of alteration pattern, and delineation of the mineralized zone on the surface itself. Because these subsurface things are very costly effort. So then what we have to do? We have to take help of geochemistry, geophysics, then complete the geological mapping. Yes, different types of mineralization has many control. It occurs on the geological environment. It is associated with fault. See here, it is associated with fault, folds, and zone of alteration, where generally we see maybe at the contact margin of two rock types, two lithologies also we may get, or also at places of your hinge zone. These are the places we could get the. This is your axial plane. So these are the places where you will get, and recognition of such places is very important to find out. So so to add to this, basic geological mapping and prospecting must be regarded as a foundation. If the basic geological mapping is not done, if the prospecting or the recognition survey is not carried on at the at a base level properly, then you think about what will happen at a later stages. So these things has to be carried out at a base level itself. So if anything is there for mapping purpose, so this particular lecture was not on the basic geological mapping, but we also conduct such kind of training program where we give the basic geological mapping technique, how it should be carried out in the field. So this is very much prima facie important requirement of any geologist. Okay, so now coming to the host rock. Yes, the host rocks, as I told you, depending on the host rock, you need to know what kind of mineral it could keep with them. What a basic rock will generally have, what a felsic rock or a mafic rock will generally have along with them. So this again favorable zones, like the greenstone belts, favorable zones like the granite and the intrusive granites, favorable zones like mostly your Archean proterozoic ultramafic rocks which are targeted for what minerals, because the Archean rocks being more ultramafic targeted for chromium, nickel, Pg, copper, and gold, followed by your younger basic rocks for gold, polymetals, and finally the recent proterozoic or much more recent, more than 2.5, the granites which have been included, they may contain more amount of REs. So the favorable stratigraphy and complementary host rock is requisite in search for the economic minerals. So again, these are the tables already done, but again we can also see the scale of mapping, as I told you about a scale of map where we talk about 1:50,000 as a scale used in G3 investigation, and in G2 we generally go for much larger scale. Okay, larger scale of investigations. So these are all based on your remote sensing, what has to be carried out in the geological mapping. These things are kept in. Okay. So detailed exploration, as I told you, detailed exploration again comes in the much larger scale. This is geochemical. Again, geochemical. See, geochemistry is dealing with the sample, and sample collection is very important. If you collect the sample properly and take the sample without biasness of your exploration, it would really help the generation. So that will be, again, as I told you, it will be cleared in the next presentation. And geophysical study, for ground geophysical study, we have spacing. It all depends on the ground geophysics, and at places boreholes are also geophysically logged. Technological, here it comes to drilling, which we have told you how the spacing decreases. So depending on the deposit type. This is for large scale mapping. I wanted to add these things. So detailed mapping, again, what are the objectives? To assess the mineral potential of the rock, trace the extension within the block, and to have an approximate idea of the in situ rock. And so these are the most important objective a person should keep in consideration when they are working with a detailed map. And see, once larger scale is done, when you go into more detail, you need to know the potentiality of the block. Then the extension of the mineralized zone, what is the depth, what is the continuity, so all that. And in situ resource, yes, in situ. Why? Because it cannot be ex situ, or it cannot be from it cannot be a like surficial. It has to be in situ. So sampling, yes. So again, just a brief introduction, and I'll finish off the slide here. So what is the main objective of a sample? To identify the rock type, and to evolve an understanding of the geology in layer plane for more detailed sampling. See, at the initial you have given a sample, then if you find something important, then we can go for the detailed sampling. And then you delineate the mineralized zone, and then finally you see what type and nature of the mineralization is possible in the strike and extension. So, okay, I think stop here. These things are repeating again. Yeah. So I hope I could explain. I could give justice to my particular topic here, because I know it's a vast topic, very vast. Exploration strategy, it is not covered in a 45 minutes or so, but I told you the basic concept and basic ideas what are being used in general to find out an area, to select an area from a large scale, and then come back to a localized scale, and in the localized scale what are the different stages being done, and what are the general mechanism followed by GSI, Geological Survey of India. So thank you so much. If you have any query, we can discuss on this. Participants, it is open for discussion.
Thank you, sir. Thank you, Lakshminarayan Deori, sir, for your wonderful presentation. Though it's a vast subject, like exploration strategies, you covered very nicely. You explained step by step how to approach the approach for targeting the mineral deposits and stages of exploration and sampling techniques, and many things you have covered within short span of time. Thank you, sir, once again. Participants, is there any queries? Sir, one query is there, sir. How is the approximate reserve estimation calculated at the G3 stage?
How is the approximate reserve estimation calculated? Okay, yes. This is little bit again what you call it. We have this session. This session will be done by Dr. R. Vijay Kumar sir. He will tell you how the calculation has to be given. But I can tell you that approximately this is in the G3 stage. We can tell this because already the drilling will be carried out in the distance of 100 meters. So we have these different functions, like we have level plans, we have cross sections, and we have all these things. So we will not go much into detail that because it will be confusing right now. So please bear with me. It will be taking in the last session today. Okay. Okay. Is it fine, Anirudh Chakraborty? I'm so sorry that I cannot include that now. Yeah. In this, what we can do, everybody is having some basic things of mapping, like how it has to be done, what are the different. In that basic thing, you can add, because this is very much only for the benefit of all the people who are doing any work in kind of geological mapping. So I can also do one thing. I will share the slide because many things were written on it. It will be helping the participants to read through it, and we will also share our personal number here. If you require, or if you face any kind of difficulty at any point of time during your mapping, we can help you.
Participants, any more questions? There is no question.
Yes. Anybody, if you want, then you can ask unmuting yourself. Then
so this is Anirudh. So there is one more question. So what do you think about the prospect of gold in the Sokoli region in Maharashtra? If you can, is it like a good deposit to explore, or is it a very small deposit which has been encountered? So
yeah, right now I may not be able to tell anything about that, but obviously, if anything is there, we will obviously find it. Sir, would you like to add to this?
How do you repeat?
Yes, our person here is asking about certain, like any prospecting from the Sokoli region, Sokoli belt region, where how prospective it is.
For Sakali region, for central India. Okay.
Central India, yes.
For gold or any other commodity?
For gold, sir.
For gold, sir.
Or gold.
Oh,
See, Sakoli is also an important place for gold exploration. Though a lot of work has been done in that area for other entities like uh, tungsten and other things. But yes, definitely Sakoli is a good place to search for. Though GSI has worked there and a few means places gold has been reported, but still it require definitely it is a very favorable place from point of structure and though the issue is that favorable litho units may not be there, but still it's a very from the point of structure and Sakoli is a good place to search for gold. Is it okay?
okay, sir. Thank you. Thank you so much.
Yeah. Not only gold, the polymetallic occurrence has been reported in Sokoli by GSE at many places.
Oh, okay, sir. So, from the mineral point of view, tungsten, I think tungsten, manganese, and
Those extensively, not manganese, tungsten has extensively been worked there in that area by
yeah.
GSI,
Okay.
and even MECL they have done extensive drilling there in that area.
Acha. Okay. And
289.
so there are copper deposits also associated because copper, gold.
Yes,
Yes.
actually
Yeah.
that's what this base metal and gold occurrences or reports has been there, but extensive work specifically for gold, except I have seen one in during our FS when I was there at Nagpur. There was one project on gold specifically for gold was initiated at that time. Though they got some values because of that some reservoir issue, they were not able to again do much justice to that.
Okay. Okay. So at the moment, there is no mining activity as such at that
No, as
region.
such, for gold, there is no mining activity there. Actually, though, officially, there is no gold mine. I don't know about illegal activities.
Okay.
Yes, because
Okay.
in India, as morning I was telling about the Gadag,
Yeah.
there, even today, illegal activity, mining activity is going on. A person who is a localite who is associated with that mine probably earlier, they're daily going into the mine, they're collecting that material and around 2 to 3 grams per day they are extracting the gold
Oh my God.
manually by manual scavenging. It is there. So I don't know about the illegal activities, but legal activity there is no as such for gold mining.
Hmm.
One more thing I wanted to add. Uh, Apart from Hatti, there are 2 3 mining leases has been granted in many like in Ganjur and many other places. Ganjur, then that Jonagiri, mining leases has been means granted, but still work has to be done. Apart from that, as a byproduct, gold has been we are getting gold from many other areas. Even that from Indalco company, they are extracting gold as a byproduct, which is more than the primary gold produced in India.
Acha. Uh,
Okay.
Thank you, sir.
I think that is okay for you.
yes, sir. Yes, sir. Thank you. Thank you so
Yeah.
much.
Thank you, sir. Thank you for enlightening the participant here with that. Yes, obviously, we need to have much more studies by by our upcoming geologists because this is an idea given by us, so that they get encouraged and they work more detailed in this kind of places. Any other information? Any other query? You undergraduate students here, I think they can come up with some questions if they have in general. Undergraduate students, I think yes, they are just gone in. They have just entered into this geology department. So yeah, it is very important that you you learn all the things, and in the recent future we may find you as a geologist in some very great organization. So then I think,
Sir.
Parsuram, sir, yeah, thank you so much, everybody, for patiently listening to the presentation. I'll be sharing it with you, and it will be helpful to you. And sir, yeah, Parsuram, sir,
I
please.
think there is no queries. If is there any queries, please ask anytime, even in WhatsApp group also. Let's assemble at 2 p.m. Sir, is it okay, sir?
No, not exactly two. At least be there 5-10 minutes early. The meeting will be open
At 1:45.
15 minutes prior. Yeah. So I request all
By
the
2
participants to
p.m.
join
lecture will be.
so that we can start the lecture on the time, and we'll be concluding as early as possible. Means there will be 2 lectures in the afternoon session, and first lecture will be by Dr. R. Vijay Kumar sir, who is the director of regional training RTD SN region, Hyderabad. So with this, we'd like to conclude the morning session. Thank you all for your patience hearing and interaction. That's see, for any training, interaction is required. Unless and until interaction is there, we will not be able to assess whether whatever we are trying to do is justifiable or not. With this, I hope to